Okay, here we go. April Fool's Day, Wednesday, and we're in chapters 9.5 and 9.6, multiplying and dividing radical expressions. And we have this property to use if you have a root of a product, something times something, x times y. It can be separated into the root of each factor, or you can start with this and go in the other direction. This will be a lot more meaningful as we use it. And notice the disclaimer here that we want all non-negative values for x and y. If you have negatives in there, then you have to worry about is the index odd or even, but we're not going to tackle that right now. So here's a square root times a square root. So I can multiply this together and change that to square root of 4x squared. Now, we want to make this simplified, which means we want to make the radicand, and that's our fancy word for the stuff under the radical sign. We want to make that as simple as possible. So if you look for perfect squares, well, the square root of 4 is exactly 2, and the square root of x squared is x. So that's the end of that. Now, I might have done this also if I wanted to really get detail-y. Break it up again into the numerical part and the variable part. And for the numerical part, it's already a perfect square. Square root of 4 is 2. And for the variable part, we want the power to be divisible by the invisible 2. And of course, 2 divided by 2 is 1. You get 2x to the first power, either way you look at it. So let's slide over here. Here's the cube root times the cube root. And if we try to simplify these individually right now, we don't get anywhere because neither one of these has a perfect cube that factors out. Now, if we multiply these together, 6 times 9 is 54. And then remember what we were doing a lesson or two ago. That's not a perfect cube, but if you divide it by 2 and then 3 and then 4 and so on, eventually you should run into a perfect cube. We don't have to go very far if we just break this up into cube root 27, cube root 2. I divide this by 2, I get 27. As a very old math teacher, I recognize 27 as a perfect cube. You could make a list, 1 to the third, 2 to the third, 3 to the third, 4 to the third, etc. This is now a perfect cube, so we'll get rid of the radical sign there. We will be stuck with this. Cube root of 27 is 3, because 3 to the third is 27. Our answer is 3 times the cube root of 2. Okay, and you can check this with the calculator by punching this in the way it is and comparing it to this. And as we don't have live classes anymore, I didn't get to show this, but if I want the cube root of something, there is no cube root key. However, if you push the math key, see the math key right here? There is a cube root command, number 4. While we were looking at this, I'll tell you number 5 is for any other index root. You put the index in first and then come back to this. And we'll try that sometime before this video is over. This set of videos for today's lesson. If I want the cube root of something, I select number 4 from under the math menu. And what am I looking for the cube root of here? 6. Cube root 6. And then I want to multiply that by the cube root of, what was the other number? 9. Cube root 6, cube root 9. Multiply those together. I get this 3.77 yada yada. Okay? Now I want to compare that to my answer, which was just 3 times cube root 2. So I'm going to type 3 times, hit the math key, hit number 4, cube root of 2, and voila, you see they did come out exactly the same. So that's telling me what I started with is exactly equal to what my simplified version is. Okay, on to the next one. It's a square root times a square root. And if I multiply the numbers together, 5 times 20 makes a nice perfect square 100. And you know, I could make this 100x cubed right now, but this is, why waste all that time? X squared is a perfect square. That's not going to go any further than that. So we change that and we change that. That becomes a 10. That becomes an x. So this simplifies to 10x square root x. Slide over here. Neither number is a perfect square. Okay, square root again. But I'll do 5 times 15. 5 times 15, I get 75. Let me combine the x's together. By the way, what I'm doing is not the absolute be-all, end-all, and only way to do this. If you watch the other lecturers' demonstrations and approaches, there's other methods, but I like mine. There's a perfect square in there. Do you see it? If you divide by 2, you get a decimal. If you divide by 3, you get 25. So I'm going to rip that apart into 25 times 3 because of 25 being a perfect square. For the variable part, we want a power of x that's divisible by the invisible index 2. So that's not divisible by 2, but 8 is. I'll factor the x to the 9th into x to the 8th x. Now this and this will change. These will stay under the radical sign. This becomes a 5. And this becomes x to the 8 divided by 2 is 4. And we have square root of what's still in there? 3x. Well, there's my answer for that. By the way, when you get this printed later, these are going to be numbered. This will be number 1, number 2, number 3, number 4, number 5, and number 6 on the first page. Oh, and sorry, number 7. Number 7 way down there. And now we're up to number 5. And it's a 4th root times a 4th root. Gosh, we're getting more complicated. Neither one of these is a perfect 4th power, 3 nor 27. But if I multiply those together, I get 81. 81 is 3 to the 4th power. That's nice. And then x to the 3rd times x to the 5th, make that x to the 8th. So now let's reassess and investigate. For the numerical part, we have a perfect 4th power number. 81 is 3 to the 4th. For the variable part, we want our exponent to be as big as possible and to be divisible by the index 4. 8 is divisible by 4, so we're ready to go. This changes to a plain old 3, and this changes to what? X to the 8 divided by 4 is 2. Final answer, 3x squared. That wasn't too bad. Let's slide over here. The parentheses are there just to reinforce the idea that it's a multiplication exercise. It's this times this. We could factor out an 8 there because it's a perfect cube. But let's just multiply these together first and see what happens. Because with the quarantine, we've got all day, right? 16 times 4, that's 64, right? And then w squared times w squared, that's w to the 2 plus 2, w to the 4th. Okay? This is a perfect cube. That's the third power of 4. 4 times 4 times 4 is 64. So that becomes 4. And for this little side note here, 4 is not divisible by 3, but I can think of that as cube root w to the third times cube root w. So this one will change to a plain old w, and we'll keep the cube root w there. And that takes care of that for exercise 6. 4w cube root w. Notice again, I'm careful with my writing of my answer, making sure that it's clear this is an index, not an exponent. And now we're down to number 7. It's cube root times cube root again. So we can multiply these together, and we will, because neither 25 nor 5 is a perfect cube. If I multiply them together, I get cube root of 125. That is 5 to the third. So we like that. And for the variable part, what do we got? Cube root of m to the 8 and 7 is 15. And 15 is divisible by 3. So we're going to not have any radical in our answer. Cube root of 125 is exactly 5. And the cube root of m to the 15th is m to the 15 divided by 3. Makes the exponent of our answer 5. And lastly, I didn't number this one. Number 8. This is multiplication, of course, and it's really, you can think of it as 4 things being multiplied. 3 times root 5 times 2 times root 5. So since it's all multiplication, we are free to rearrange the order of the things being multiplied, the order of the different factors. And this is handy because I can just change the 3 times 2 into a 6. I can change that into square root 25, and that's lovely because that's a perfect square. That becomes a 5, and so my final answer here is a plain old 30. Okay, that's 12 and a half minutes. I think that's long enough. See you in the next video.